Hey, fun science video for you. Hey, during all this coronavirus stuff, this might be a fun thing for you to try. It's a fun little science experiment. You need a few materials. For those of you in my class who need to do this, if you watch my demonstration at the point when I say pause, so you can try it for yourself, you could just continue to play from that point and you can actually see what would actually happen. But it'll still work for you. I thought it would be good today on this day for you as a student to be able to do a fun little demonstration at your house if you have these materials. If you don't have these materials, like I said, just watch the video all the way through and you'll still be able to get to see it. So in class, we've been talking a little bit about taking hydrogen. All right, this is a molecular model for hydrogen. And we've been talking about taking the hydrogen molecule, and when we combine it with oxygen, we end up creating water vapor. And this is our water vapor molecule. And we talked the other day about how when hydrogen does this and it explodes, it releases a tremendously large amount of energy. And that's evidenced by the big explosion you saw a couple of days ago when you were watching the videos. Well, what's interesting as well, though, is today we're talking about how energy, in the law of conservation of energy, says that energy cannot be created or destroyed. And so one question that you were asked is, well, where does the energy come from when hydrogen explodes? And the reality of it is that it's actually stored in this bond right here. There's a tremendously large amount of energy that is stored in that bond. And in order for that energy to get there, okay, if we were to take water and reverse the process and go back to hydrogen, you would need to put energy in. So when we blow up hydrogen, we release energy. But to get it to go from water back to hydrogen, you're going to need to put in energy. So today, here's the materials you need if you want to try this at your house. First of all, you need a clear cup, all right? Second of all, you need a 9-volt battery. Okay, these are the square ones that a lot of you have in your smoke detectors. If you do take one out of the smoke detector, make sure you put it back. Third, you need to try to find 2, all right? I don't know if you can see that or not, but you need to come 2 thumbtacks or push tacks, the ones that are metal. And lastly, the last material you need some baking soda, all right? So you need less than a half a teaspoon of baking soda. So the first thing you would do if you want to try this experiment at your house, you need those materials. So the first thing that you would do is you would take a battery, a 9-volt battery, and you would put it underneath the cup like this, and you would take a Sharpie or a permanent marker, and you would draw right near the middle 2 circles where those 2 contact points are. Once you do that, okay, you can see that I put 2 circles on this one with a blue permanent marker. The second thing you would do is you need those to be perfectly spaced apart. So what you would do next is you would push 2 thumbtacks with the flat spot down and the pointy part through the cup. So on the bottom of the cup, again, the flat part of the thumbtack or the push tack and the pointy part coming through at that space so that when you put this 9-volt battery on this, it will be on those leads. Okay, and that's what you would do. All right, so what we're going to do right now is for those of you who want to try this, okay, you would go ahead and make your cup, put the thumbtacks in it. All right, once you got the thumbtacks in, you would put water in a cup, and then you would put less than a half a teaspoon of baking soda in, and that's important because that's going to help get the current of the battery to flow through the water. If you don't do that, it won't work. Okay. So what I want you to do right now is if you decided you're going to do this on your own, you're going to pause the video right now and you're going to try it. Okay. And what you're going to do when you try it is you're going to put the battery with the water onto the leads like so. And when the water's in there with the baking soda, you're going to actually be putting electric current into the water, and you're going to take the water molecules and you're going to turn them back into hydrogen and oxygen. And you're going to see bubbles coming off of those thumbtacks. So if you decide to do this without me right now, what you're going to do is you're going to try to determine which side do you think is the hydrogen and which side do you think is the oxygen. I'll give you a hint. The molecule H212O should give you an idea that one of the two gases, there should be more bubbles coming off one of the sides. So what I want you to do is I want you to try it. And what you're going to do is you're going to put it where the leads are one way and look at the amount of bubbles coming off. And then switch it and put it the other way and see if the one with the higher amount of bubbles stays on the same side, either the positive or the negative of the battery. So if you're going to try on your own, pause the video now. If you're not going to try on your own, okay, because you don't have these materials, I'm about to show you what would happen. So pause the video if you want to do it on your own. If you don't have the materials, here we go. Let's watch what happens. So I'm going to get these going on there. And hopefully you're going to be able to see when I get my fingers out of the way. And as you can see right now, maybe a little tough to do that and video, you can see that in your screen, one of the sides has more bubbles. It's the one where the side where I'm kind of pointing right now and moving my finger. That side has more bubbles forming on it than the other side. So that, just so you know, that is the hydrogen side. That is the hydrogen side. Now on the other side, you've got less bubbles forming, and that again is the oxygen side. Now I'm going to switch this, and when I take the electric current off, it stops, but I'm going to switch it, and now if I switch it, you can see that there are now more bubbles on this side where my finger is than there are on the other side. So again, that's the, oops, kind of losing my, there it goes, maybe. It's really hard to keep that in the screen and get you to see everything you need to see. Let me try this again. Keep losing one of them. There we go. So there you go. You can see one side has more bubbles and the other side has fewer bubbles. That is so cool. So this, by the way, is called electrolysis, is what this is called. And science is awesome. So if you have a chance to do this today, what's kind of cool is that hydrogen, remember, gave off a tremendously large amount of energy. And that's why it was an exothermic reaction. And to get that energy back into that molecule, we have to take electric energy and put it into the water, which goes back to breaking that bond of the water molecule, the covalent bond of the water, and then it puts that energy back in the hydrogen bond. So this is not endothermic. This is not exothermic, excuse me. This is endothermic. Whereas when we blew up hydrogen, it was exothermic. So anyway, that's really cool. Science is fun. Hopefully you are surviving the corona virus and your family and you are safe. Have a great day, and we'll see you soon, hopefully, back at school. Bye, guys.